Bonjour à tous. That's the extent, I'm afraid, of the French for me today, so I apologise for all those who will have to put up my English from now on. Okay, so low power WAN, cellular networks. That's what I'm here to talk about today. I want to really try and get across, if I can, the opportunity, which many of you here may already know about. Hopefully for those who don't, it gives you a sense of what's coming, a sense of the potential in these markets. And I'm going to be focusing on the LTE-M and the NB-IoT elements of low power WAN. I know you have today other speakers that will concentrate on the other technologies, so I'd like to thank EBDS for giving us this opportunity, and Captronic and all the organisation that's gone into this day, particularly from Marie from EBDS, and it's great to see so many people, so many faces here today to come and interact with us. So I work for Siretta. I'm marketing and production manager at Siretta. I've been with Siretta for 10 years. We're manufacturers of wireless technologies. Our main focus is cellular. We provide and supply modems, routers, cellular signal analyzers, so if you need to test and survey the network, then we have a unique piece of technology which you can see today. And we have many antennas, all of different mounting styles. What I'm going to cover today is an overview of the cellular networks. I'll give a little bit of a display of the actual makeup of those cells. Then we'll move on to the 4G LTE and how that specifically shrapnels and fragments into the technologies that we have today. I'll then look at trying to give a sense of the features, the advantages, the benefits of going with this technology, and look at the markets and applications for this particular technology. So, cellular networks. If we look over here, we have the basis of what I'm talking about here, the cells. These are all connected. If each one of those hexagons is taken as a cell, then they are connected by an internet backbone. You'll see that there are letters on each of these cells. Each letter A is the same frequency as letter A anywhere else, and the same with letter B corresponds to another frequency, but all the letter B's are the same cells, and that's the same frequency. So that will come to light shortly as to why that is the case in this particular diagram. So we'll look at the makeup of the cells, and then we'll look at the registration. These are all the basic things of setting up the cellular network. So we've said they're joined together by the internet. Neighbouring cells typically use different frequencies, so you don't have any interference from one cell to the other. With the lettering that I mentioned before, each letter A has the same frequency as letter A in other clusters, and the clusters are bordered by that the dark black banding. There are 3 network clusters within this particular diagram, and that's what makes up each country's wide area network and allows the communication, allows you to get onto that network and communicate across a very wide area. The frequency separation allows this setup to become a very densely populated network. And when we look at how you actually get onto that network and the registration process, the base stations represented by this diagram here and a mobile in the middle transmit what's called a broadcast control channel beacon, and the mobile network operators transmit a system identification code on that channel, and your device is listening out for that channel. Once the system identification matches from your mobile to the network operator, then this is sent via the mobile switching centre, and access is granted to your particular device to get onto the network. The other important part about this is the mobility and handover. So effectively, if you're in this bottom cluster here on cell A, then you can move roam to the next cell with staying on channel A. So this is what makes the handover so much smoother. So if you're on cell E, for instance, you would, if you wanted mobility, you would move to cell E on the next cluster. So that gives a little bit of foundation on the cellular network. How are things actually governed, though? What keeps things together? What makes the standards that we all operate to work? Well, there was a body set up in 1998 as a result of an initial merger between Nortel and AT&T that formed the 3GPP partnership program. And this is what governs all the control standards that we see today. And what they do is they meet on a regular basis. The pandemic obviously has held up a lot of the regular meetings that these guys used to have. But there are obviously a number of online sessions conducted as a result. But we are a bit behind. And currently you will see things moving on this year, probably around the mid-year time as new technology comes out and gets launched. But effectively, it's a strategic initiative. It involves many partners. It involves people like representation partners such as the GSMA, who many people will know, the IMS. And what they do is they make observations, they work in technology standards groups, they look at particular study items within the cellular networks, and they issue releases. So back in 1998, the first of those releases would have come out, and every so often a new release comes across, and we'll be looking shortly at those releases. But if we look at LTE particularly, that came in release 8 in 2008, and there is always a lag period. You get the inception of a particular release to start with, and then you get the launch of a release maybe a year later, possibly 2 years later in some cases. But each release looks to improve on the previous release, looks to improve the network. So with LTE-M and LTE NB-IoT, we have a release of that in 13, so a few years ago, 2016, that took place. And currently the releases are looking at improvements on that, but also the inception and launch of 5G. So the current releases are spanning across that. This is a sort of representation of what a release may look like. So it's made up of a number of radio enhancements, a number of system enhancements, and there has particular reference in this current release. This is release 16 we're showing here, to the 5G efficiency. But essentially, the key elements of the releases look at the radio interface, the core network, and speech coding. You can see here, if we focus in on some of the more significant things regarding LTE, in release 8, LTE came in, and you can see that particularly here we have reference to VoLTE. So this is the opportunity to communicate by voice over the LTE network. Previously with 2G and 3G, this was done through circuit switching and an analog network. As we move across, further things happen with regard to release 10 and release 12 with the downlinks and uplinks in different classes. And then we come to 2016, where you have the narrow bandwidth 1 standard for NB-IoT, and then the class M1 for LTE-M. So that was really where things started to fragment within the LTE technology and bring us something that's more of the M2M and IoT market. One of the key things in the characteristics for LTE is the frequencies are for uplinks and downlinks. So in order to transmit from the user equipment to the base station or vice versa. And this is done in one of two ways, and particularly most people here will be dealing with European markets and the frequencies, or the frequency division duplex FDD. TDD is the other way of doing this transmission and receiving, time division duplexing, so time slicing, and you'll see that particularly in a lot of the Asian markets, China, etc. So what happens with the frequency division is that the channel has one channel for uplink and one channel for downlink, as displayed on the diagram here, and it has channel spacing, which is called the guard band, which allows it to make sure that there's no interference between the two. This is particularly strong for lower frequencies, where signals are travelling a further distance, whereas the time division is much more efficient at higher frequencies, and you can get quite a bit of flexibility in the size of these transmissions or receiving states as you time slice. But again, there's a guard interval between them, and TDD is therefore travelling a shorter distance, but much more useful at higher frequency. This just gives you a quick snapshot of the popular frequencies used in Europe and North America. We're now starting to see that the introduction of 700 megahertz as a popular standard, I know is one of the frequencies that are developing here in France. This gives you an idea of just the scale of the cellular network, and you know what you're joining if you're looking to deploy cellular technology. This is a heat map. It's taken from London, and essentially you can see how swamped that is by base station transmissions, and most cities around the world will be very similar to this in terms of the density of cellular transmissions. And as you get you spiral out into the countryside, obviously those heat spots get less and less. But you're also joining a big cellular ecosystem made up of mobile operators, infrastructure companies, and of course there's a huge number of subscribers that are interacting with these base stations every day. This tries to give you an idea of the scale. What you see here in the middle are literally all the base station cells that are picked up through the cellular signal analyzers that we have and we manufacture at Siretta. And this again is just focused on inner city London, a very central area of London, and you can see the scale of this, the density of some of these base stations in just a small clustered area, just to give you an idea, the 2 kilometre scale. So there'll be other clusters next to this and beyond. So very, very dense. And this is a mixture of 2G transmissions, 3G transmissions, and LTE, represented by the different colours. Then if you go to a more rural scale, you can see that you know, for the same number of base stations, we're going to 10 times the distance to give the same density. Okay, so we move on to looking at the 4G LTE, and in particular focusing in on the low power WAN, so just focusing on LTE-M and NB-IoT. So as we mentioned before, one of the key things is the frequency, looking at the TDD or FDD, the frequency bands that are used, the speed, and the MIMO layers, so the multiple input, multiple outputs, as this relates to the number of antennas that you can use. At the lower levels, the LTE-M and NB-IoT, one antenna is sufficient, but as you move up to maybe LTE category 4, you maybe want to look at diversity, which this would support. As this is IP based, it means that there's a reduced latency the 2G and 3G networks. There's no circuit switching, so the base stations can support the IP traffic over 4G and particularly voice traffic. There are also support for, as you see, with text for SMS, so lots of legacy things that are useful to people still supported within LTE. It moves on really from the 2G and 3G best practices. The bands and regions as of February 22, different regional areas supported by different bands. We have 59 defined bands within LTE. 39 of those are frequency division duplex and 20 of the time division split. So what we've seen over recent years is the fact that as the cellular network has developed, it's largely been designed around the consumer from its early inception, and that's meant for people in M2M and IoT that there's been a lot of costs involved working on a network that was designed for the consumer, and as that's progressed, it's got into things like streaming and video and very high bandwidth applications. Largely in terms of M2M and IoT, most people want to transmit on an infrequent basis, low bandwidths. They maybe only want to interrogate a cache box once a day or find out how much fuel has been used once or twice a day. It doesn't need the great benefits that the whole of the Category 4 LTE would offer. So there was a big push, and you saw in the early release 13, that this now started to fragment into the technologies that we've seen today, LTE-M and NB-IoT. These technologies are still in their infancy period, they're growing, but there was a lot of pressure to get to this stage and also to provide lower power and lower costs for people in IoT. So we had the release, as we say, in release 13. It also meant that as there was already LTE infrastructure, it provides a low-cost entry point for people wanting to enter into this market. And this is how typically the fragmentation looks. So if you look at the data rates on the left-hand side here, and you look at the existing technology, so people within 2G and 3G generally migrating across to LTE would fit into these categories. So at the higher speeds of 3G, HSPA+, you're likely to want to go into the Category 4 LTE, and the other attributes as you move up the further categories, and things like Category 6 coming along, etc. 3G in a more slower lane would tend to point people towards LTE Category 1. And that's a very attractive technology for people looking to migrate from 3G. And very easy to slot into. For the lower data rates, the lower bandwidth, we look at LTE Cat-M first, and then if you really have got very low data rates and you want to travel further with this signalling particularly, then NB-IoT is the technology where there's a very dense level of transmission, and it means that you can actually travel probably up to about 7 times the distance on NB-IoT than you can on LTE-M. So it makes it very good particularly for underground applications. Here's a comparison then of those two low power WAN technologies, and you can see that in these first few lines you're getting that distinct definition of a slower technology, latency is higher versus the LTE-M. So if you need something that's that bit quicker, then this is the technology to be looking at. But the idea of one of the ideas of NB-IoT and LTE-M is this ability to provide technology that is using such low power that it opens up battery applications. And so one of the things that was the directive set out, the release set out, is that this would suit battery applications that are designed to run for 10 years or more. And it's easy to say that. Obviously, in practice, there are a number of things that you need to take into account, and obviously, if there is any power consumed in trying to just get onto the network, it may well be that that application doesn't run for 10 years, but you get the idea that it's there for a permanent period. You can also see that we have here, in favour of NB-IoT, very good indoor penetration. So this again just backs up this idea that NB-IoT is good for the underground technologies. And NB-IoT also works at what we call the edge. So in terms of the sensor market, sensor technologies, you can go straight to the sensor and get your transmission back using NB-IoT. It doesn't need a gateway to bring you that information back. So very good for opening up massive machine technology, whether that's in factories or whether it's in agriculture. There are a plethora of opportunities that this is going to bring through the fact it's low-cost technology, and also it's consuming low amounts of power. And very importantly, as we mentioned before, the infrastructure is already there. So in order to get on to the LTE network, there's got to be hardware and software upgrades. But these are now starting to be performed, decisions are starting to be made by the network operators and suppliers into this market. With regard to LTE-M, this can exist on the current LTE network, it just requires a software upgrade. And that's what's starting to happen in many markets now. And we see this is the GSMA latest technology, latest report, should I say, from 2021. 158 commercial IoT networks around the globe, and you can see from the colour key system here that in the claret colour here, these are where both LTE-M and NB-IoT technologies coexist. Now, for instance, in the UK, that is split with the west side of the UK, it tends to be NB-IoT. The east side of the UK is LTE-M. LTE-M supported by the operator O2 and NB-IoT supported by Vodafone. And this seems to be the way some of these markets are operating. So where you look and you see the claret, it doesn't mean that the whole country is necessarily NB-IoT or LTE-M. So it's very important really to look at the markets that you're targeting your product at and ensuring that you do have that coverage. But this is starting to pick up pace. There have been some little bumps along the way. For instance, in Japan, I know that Docomo took the decision to withdraw for the time being on their NB-IoT network after setting it up. But it's an exception rather than the rule. And so we start to see the spread of this, and you can see obviously predominantly here this is NB-IoT in this region of the world, and in the Mexico area you have the LTE-M only. So important that we look at the markets where we're looking to deploy, but if you want to go into, if cellular is your option, then you have got a global infrastructure which you can tag on, and gradually countries and regions will start to fill up. Okay, so to cover some of the things that are really poured out by the providers for NB-IoT and LTE-M. The common attributes of both of these technologies is that if you want to run for extended periods or in battery-powered applications, nominally this 10-year cycle, then NB-IoT and LTE-M are really where you need to be. There are obviously a large number of connections that these are both capable of, so they really suit the massive machine market opportunity and anywhere where there's big scale for IoT products. They both use licensed band spectrum, so they don't have to coexist with other technologies. The things more important maybe to NB-IoT is the implementation, the execution of these directly onto sensors. So this is really going to open up over the next few years the application of this technology with regard to sensors, whether it's measuring soil moisture or looking at pollution. This technology is going to make a difference, and as we've reiterated a couple of times, underground applications are going to be suitable for NB-IoT. As far as LTE-M is concerned, they make the most of what's another outlined statement within Release 13, which was to provide power saving modes. So this puts your devices into a sleep state, and this is where great power savings can be made. There's also this term extended discontinuous reception, EDRX, which provides for periodic wake-up states. And again, you can imagine the power saving that goes on versus the legacy technologies. So in terms of LTE-M, we're talking about a tenth, roughly, of the power, and also reduced latency. So again, the fact that you're getting your message across without too much latency is again another power saving attribute. There are also improved encoding techniques, and all of this will enhance network performance, and it's operating using full duplex, but there is the opportunity to operate in a half duplex fashion again to save power. As far as general IoT compatibility is concerned, how does that suit these two technologies? Well, as we said, they can both operate straight away on LTE infrastructure. It's a low-cost investment route because you're tagging onto infrastructure that's already there. CAT-M particularly is really starting to move across the globe, and there's plenty still left in the tank to go as well. I mean, overall, between LTE-M and NB-IoT, it's expected that somewhere in the region of about 60% of the low-power WAN connections, which are in the billions, will be on those two technologies around about 2026, 2027. So very low latency, suits the use cases where we talked about before, where you want a faster response. There's roaming capabilities with LTE-M. There isn't currently with NB1, but NB2 does start to offer some ability with that technology, but the current time NB-IoT does not offer that roaming capability. And this low cost of entry for NB-IoT will see that applications explode for those over the next few years. Okay, so very quickly to give you an idea then of markets, and some of those I've mentioned as we've gone along. Typical of probably what most people have seen already are involved in cellular applications. But we expect to see, particularly with things like agriculture and smart cities, etc., building infrastructures, a lot of new applications coming in. We, as a company, have mainly started in the transport and traffic area. That's where we've seen our technology develop over from 2G through 3G to LTE. So those have tended to be very strong pillars for the machine-to-machine market, as well as utilities and security. But we expect to see some of those other markets now really starting to expand as we go forward. And just to put in perspective some of the applications, you can see obviously those applications that require the higher speeds and the higher bandwidths will be tilting towards LTE category 4 and LTE category 1. But we've seen with certain customers, even who started to migrate from, say, 3G into LTE category 1, that there's some of those now are starting to come down again and look at LTE Cat M, because they don't require the extra bandwidths and data speeds that LTE Cat 1 offers. So here are some of the typical things that we get inquiries about, and I know our distributors do as well, in all of the different applications that maybe we've not seen before, but certainly things like predictive maintenance in factories is going to be an area that we will see expanding. So what about the future? Well, having gone through really where we are with LTE, what's happening, what's going on in the background with 5G? Well, if you do opt for LTE-M or NB-IoT, the current releases from the 3GPP cover the support of LTE Cat M and NB-IoT going forward. It won't support the current LTE Cat 1 and Cat 4. However, 5G will have its own native versions for Cat 1 and Cat 4. And if you're already investing in LTE Cat 1 and Cat 4, you'll probably know that it's going to be around for a long time yet. So it's not as if you need to start thinking about swapping at this stage. But this whole term is going to come under what's called RedCap, or reduced capability, the reduced capability part of the 5G specification. So RedCap, you'll sometimes see this referred to as New Radio Light or NR Light, and it will provide low complexity, reduced bandwidth, and all things that really suit people who want to move into low cost technology and low power, and ensure that we have a greener world going forward. So that concludes my presentation. I'd like to thank you for your attention, and now ask you as the audience if there are any questions. Thank you.